Hello everyone. Welcome to the next lecture on the CSIR NET December 2025. Today I will explain you the few questions related to the real analysis and the ordinary differential equation. Myself Dr. Harish, you can follow and subscribe my YouTube channel. If you are interested to join with me, you can scan and join my 5th WhatsApp group, which is always free of cost to every student. Now, in this lecture, I will explain you the few questions which are related to the part B and part C. The first question is related to the uniform continuous. Second question is related to the differential equations and it comes to the Taylor series. Third question is related to the real analysis. Again, it's a part of the sequence. Fourth question is related to the uniform convergence, which is again the part of the real analysis. And the fifth question is related to the bounded function continuity, uniform continuity, and so on. How you can solve all these questions in a very simple manner, I will explain you with the help of the shortcut tricks. But before I can start my video, you can scan and join my WhatsApp group if you are really interested. Now, how you can solve such kind of the questions in a very simple manner. How you can solve this question within the 1 minute time period. It's a very simple way. So I hope you can subscribe my YouTube channel. First of all, what is the tips I will give you? If you look about the options, they are talking about the compositions. F circle G, if I say F and G both are my uniform continuous, then you can say F composition G is uniform continuous. Moreover, G composition F is also uniform continuous. Fine. So that means the objective of this question is, because F is already given to you is a uniform continuous, so your target is to prove whether G is uniform continuous or not. That is your target. Clear? इतना समझ में आ गया? Clear? Now, अब कभी भी यूनिफॉर्म कंटिन्यूस को प्रूव करने के लिए सबसे पहला पॉइंट क्या देखना होता है आपको? Whether the function is continuous or not. Now you can see the breaking point is my 1. Clearly say the limit of the G when x approaches 1 negative, which is same as limit x approaches 1 positive, and which is same as of G of 1. That means the function is my continuous. Clear? The function is continuous is fine. Now how you can check about the uniform continuous? Because we know if the function is not continuous, that implies function is not uniform continuous. Now in this case the function is continuous, so that first condition is satisfied. Now you can see there are the two cases. The first case is whenever x is lies between, that means you can say that whenever x lies between the open interval 0 and there is a semi-closed interval. And the second case is whenever x belongs to the 1 comma infinity. If you look about the function g, clearly say the function g is my linear. Fine. And once the function is my linear, it will satisfy my Lipschitz condition. Fine. And once the function will satisfy my Lipschitz condition, moreover, every linear function is my continuous. Function is continuous, function satisfy the Lipschitz condition, that means the function is my uniform continuous over the domain 1 comma infinity. एक बात और याद रखिए बच्चे यहाँ पे, whenever you have the domain like say a comma infinity, any function, let's say g of x, is uniform continuous if and only if g is my linear polynomial. Fine. If g is my linear polynomial, अगर यहाँ पे x क्यूब होता then it is not a uniform continuous. अगर ये linear है तभी ये uniform continuous होगा. So that means ये वाला पार्ट तो आपको uniform continuous मिल गया. अगर मैं ये फर्स्ट वाले पार्ट को भी यूनिफॉर्म कंटिन्यूस प्रूफ कर दूं, देन माय जॉब इज ओवर. फाइन. नाउ वी विल सी. एक रिजल्ट आपको पता है. सबसे पहले ये देखिए, अगर मैं इसको क्लोज इंटरवल ले लेता हूं, द फंक्शन क्लोज इंटरवल इज माय कॉम्पैक्ट. फाइन. मोरओवर द फंक्शन एक्स स्क्वायर which are defined on the close interval 0,1 is my continuous. Fine. The function is my continuous on the closed interval, that means the function g is my uniform continuous. यही होता है आपके पास रूल. Fine. If the function is continuous on the closed or compact, or you can say closed and bounded, that's a compact, then you can say it's a uniform continuous. Now, what is the result is, if G is my uniform continuous on the set A, then G is uniform continuous on the subset of the A as well. Now clearly say 0, 1 is the subset of the closed interval 0, 1. Now the function is continuous on the closed, uniform continuous on the closed interval 0, 1. That means the function is uniform continuous over the semi-open interval 0, 1 as well. So that means you can say G is my uniform continuous. Once your F is uniform continuous, G is uniform continuous. That means both F circle G and G circle F are my uniform continuous. And that's the given proof or the answer of this required statement. चलिए next question चलते हैं. Next question is related to the Taylor series. Now, it's a second order differential equation. Fine. If I say it's a P of X y dash plus Q of X y is equal to 0. Now this second order differential equations will possess a Taylor series solution. कब करेगा? When your P of X and G of X has analytic. Fine. जब ये फंक्शन px and gx आपके एनालिटिक होंगे, देन इट विल पोजेस दी टेलर सीरीज सॉल्यूशन. और यही इसका कंसेप्ट है स्टेटमेंट का. अब मैं अगर यही रूल यहां पे लगाऊं फॉर द p केस, फाइन, ये क्या हो गया आपका p इज माई 0, सो दैट मीन्स योर q ऑफ x इज माई e रेज टू पावर माइनस एक्स स्क्वायर. आई कैन रिटर्न एज e रेज टू पावर. क्या ये फंक्शन कभी इंफिनिटी होगा? It can never be infinity. That means this function is always analytic. Fine. So the function has a Taylor series expansion about the point x is equal to 0. Moreover, this is analytic for all x. Is it okay? Now look at the second. For the q, the function q of x is, I can write as 1 over e raised to power 1 over x square. Clearly say this function is not analytic at x is equal to 0. फाइन. क्यों नहीं है? बिकॉज जैसे आप x इक्वल 0 फिल करोगे, ये वैल्यू कितनी हो जाएगी आपकी? इंफिनिटी. दैट मीन्स द टेलर सीरीज एक्सपेंशन अबाउट x इक्वल 0 इज नॉट पॉसिबल बिकॉज द फंक्शन qx इज नॉट एनालिटिक. Fine. So that means Q statement is my wrong statement. The answer is A is the only right answer of the problem. आप more details आप ordinary different आप you can see the playlist CSR UGC net, और इस playlist के अंदर आप power series solution को ढूंढिए. If I look at the power series solution of the ordinary differential equation, let me scroll down for you. You can scroll down this complete power series solution. You can see it's a radius of convergence. Now you can see the power solution, IIT JAM and CSIR NET question solution. In this playlist or in this video, you will see the complete solutions given here. There is one more lecture. There is a power series solution in the ordinary differential equation. That's a GATE 1996 to 2023. इस lecture में I already explained the concept of the analytic functions. So in this case, the right answer is A is my correct answer. Okay, look at the next one. That is the sequence. We all knows if xn converges to the L, xn plus 1 will also converges to the L. So if I take the supremum of the xn, if I take the limit n approaches infinity on equation number 1, then it will be xn plus 1, which is 1 plus limit n approaches infinity xn square over n. So that number will be L which is 1 plus limit n approaches infinity L square over n. Now clearly say this limit will by goes to the 0. The answer is L is plus root L. That means L is my plus minus 1. But we all know the positive, the given initial value is my positive. Fine. So therefore it converges to only plus 1. So the right answer is A is the correct option. Rest options are cancelled. On the other hand, if my initial value is say my minus of 3, because this number is my negative, fine, then it will converges to the minus of 1. क्लियर? आपको हर क्वेश्चन हर सॉल्यूशन इसी लेक्चर्स में मिलेंगे भी. You can watch about the sequences of the functions, or moreover you can see the infinite series. You can see the lecture on this series. You will get the same solutions in a similar manner. उम्मीद करता हूं वीडियो को लाइक जरूर करेंगे आप. चलिए look at the next one. Which of the following sequence converges uniformly? चलिए सबसे पहले क्या टिप्स converges uniformly. किसी भी सीक्वेंस को यूनिफॉर्म कन्वर्जेंस के लिए आपको क्या प्रूफ करना होता है? द फर्स्ट थिंग यू हैव टू प्रूव दैट इट इज अ पॉइंट वाइज कन्वर्जेंस. फाइन. पॉइंट वाइज कन्वर्जेंस की डेफिनेशन क्या है? एफ एक्स लिमिट एन अप्रोचेस इंफिनिटी एफ एन एक्स. आपको ये चीजें एग्जाम में तो नहीं ना लिखनी, ये तो आपको अपने दिमाग में रखनी है. ओके, तो इसकी लिमिट निकालते हैं पहले. एफ एक्स तो क्या होगी? whenever n approaches infinity, fine, तो ये लिमिट कितनी होगी? 0. fine, so that number will be -1 less than x less than 0. fine, the answer will be -1. Second is 0, it is also 0, that means x is equal to 0. Answer is when x is 0 and x will be my 0, and this number will be 0 less than x less than equal to 1. Answer is +1. Is it okay? Now since the each limit exists, therefore the sequence fn is pointwise convergent. ये तो क्लियर हो गया. अगर यही पॉइंट वाइज कन्वर्जेंट ना होती तो आप कह देते सीधे कि इट्स नॉट ए यूनिफॉर्म कन्वर्जेंट. अब आप ध्यान से देखिए, अब इंटरवल की बात करते हैं. पहले इस इंटरवल को लेते हैं. एट एक्स इज इक्वल टू 0. फाइन, ये फंक्शन एफ एक्स कैसा है? एट एक्स इज इक्वल टू 0, यहाँ पे 0 है, इट्स -1. एफ एक्स इज माई डिसकंटिन्यूस फंक्शन एट एक्स इज इक्वल टू 0. अगर ये डिसकंटिन्यूस फंक्शन है, दैट मीन्स एफ एन इज नॉट यूनिफॉर्म कन्वर्जेंट ऑफ द इंटरवल जिसके बीच में आपका एक्स 0 आएगा, ऑफ एनी इंटरवल विच कंटेन एक्स इज इक्वल टू 0. ठीक है, सो दैट मीन्स द फंक्शन इज नॉट यूनिफॉर्म कंटिन्यूस ऑफ द इंटरवल विच कंटेन्स एक्स इज इक्वल टू 0. तो यहाँ पे एक्स 0 आ गया ना, इसका मतलब ये फंक्शन यहाँ पे कंटिन्यूस यूनिफॉर्म कन्वर्जेंस नहीं होगा. यहाँ तो ओपन है. फाइन, लुक एट द सी केस. इट इज -1/10⁻²025, 1. Clearly say 0 belongs to this case. Again, it is not uniform convergent. Look at the third case, fourth case. It's a -1/10⁻²2025, 1/10(2025). Again, 0 belongs to this one. It's a negative, it's a positive. इसका मतलब यहाँ पे भी यूनिफॉर्म कन्वर्जेंट नहीं होगा. तो ओनली राइट ऑप्शन इज बी इज माई राइट आंसर. हाउ बी इज द राइट आंसर? वी कैन सी एट एक्स इक्वल 0 इज नॉट यूनिफॉर्म कन्वर्जेंट. अब आप दूसरा पॉइंट चेक कर लेते हैं. What will happen at x is equal to 1? The function is continuous. Fine. What is the value of the fn x? At x is equal to 1 is a 1. So by the mn test, you can see what is the value of the fn minus f is a supremum. Fn x is 1. What is the value of the fx? 1 x is equal to 1. It's a 1. Clearly say which goes to the 0 as n approaches infinity over the complete domain -1 to +1. Therefore, by the mn test, the fn converges uniformly. It contains 1. So the right answer is B is my right answer. लेकिन आपका टारगेट है सिर्फ ऑप्शंस को डिस्कार्ड करना, जो रह जाएगा दैट विल बी द राइट आंसर. Kindly like and comment on the video as well. चलिए look at this another one. F is a function defined from the 0 comma infinity to 0 infinity. F is a uniform continuous, many zeros, bounded and so on. चलिए both are continuous and so on. Bounded function. So पहले bounded, okay, many zeros की बात कर लेते हैं. Whenever x is greater than 0, fine. What is the value of the root of, okay, what is the meaning of the 0? 0 मतलब आपको एक ऐसा फंक्शन निकालना है, your target, एक ऐसा, your target is to find the value of the x so that f of x will be 0. Fine. So whenever x is greater than 0, root x over 1 plus root t upon 1 plus t square is always greater than 0. Fine. अगर ये greater than है then integration is also greater than 0. Fine. If integration is greater than 0, that means f of x is always greater than 0. What does it means? Can you get any x so that f of x is equal to 0? बिल्कुल भी नहीं होगा, because यहाँ पे strictly greater than 0 है, आपकी डोमेन strictly greater than है, that means there is no zeros of the fx. Fine. So there are finitely many zeros. ये ऑप्शन तो आपका पहले ही कैंसिल हो गया. क्लियर? चलिए, now look at the second options. They are talking about the bounded. How you can prove about the bounded? That means your target is to prove it is less than equal to something. So we can start with the modulus of the f. That means it's the integrations of the root of t divided by 1 plus t square. It must be less than equal to, if I take integration is outside, then fine. Clear? Now, because it is bounded, domain क्या आपकी, it is not given, that means for all 0 comma infinity. तो जैसे ही आपका t की वैल्यू इंफिनिटी होगी तो ये वैल्यू आपकी, ये हमेशा पॉजिटिव है ना नंबर, तो मैं इसको मोड खत्म कर सकता हूं इसका, बिकॉज इट्स ऑलवेज अ पॉजिटिव. फाइन. नाउ दिस इज ऑलवेज बी लेस देन इक्वल टू, fine, because 1 plus t square is always greater than t square. Whenever t is greater than 0, then 1 over 1 plus t square is always fine. Otherwise आप इस तरह से भी देख सकते हो, what is the degree of the numerator? Degree of the numerator is half, degree of the denominator is 2. तो मैंने आपको क्या रूल बताया था, जैसे डिग्री ऑफ द न्यूमिनेटर लेस देन होगी डिग्री ऑफ द डिनोमिनेटर, इसकी लिमिट किस पे चली जाएगी आपकी, दैट विल गोज टू द 0. इसका मतलब इसकी लिमिट, दैट इज अ मैक्सिमम वैल्यू आपकी कहां तक चली जाएगी, आपकी 0 तक चली जाएगी. और अदरवाइज आप यहां से देख सकते हो, इट विल बी 3/2 and it goes to a 0 as t approaches infinity. Fine. तो इसका मतलब आपके पास mod is less than of the finite value. Therefore, yes, this function is my bounded. Clear? Now you have to check whether f is bounded, f is uniform continuous and f dash is a continuous. चलिए पहले f dash की बात कर लेते हैं. What is the value of the f dash? If you take the derivative, this number will be root x over 1 plus x square for all x belongs to the 0 comma infinity. Now clearly say 1 plus x square is my continuous over the domain 0 comma infinity. Root of x is my continuous over the 0 comma infinity. That means root x over 1 plus x square is my continuous. Therefore, f dash is my continuous function. Look at the first part, whether f is a uniform continuous or not. तो इसके लिए क्या चेक करना पड़ेगा आपको, firstly you have to check whether f is continuous or not. Fine. Clearly say this function is my continuous. Fine. Root t divided by 1 plus t square is my continuous. So then the integration is also continuous by fundamental theorem of the calculus. That means f is my continuous. Is it okay? Now how you can check about the continuity हो गया आपके पास. अब आप लिमिट्स चेक करनी है आपको whenever x approaches to the zero, or you can see f dash is my, यही आया था ना आपका, हमने क्या प्रूफ कर दिया, f dash is my bounded. इससे क्या मतलब होता है, f dash is bounded means it will satisfy my Lipschitz conditions. Once it satisfied my Lipschitz condition, that means the function is my uniform continuous. Once the function is uniform continuous, yes, the A option is also correct answer. So A, C and D are my correct options, while the second option, that is a B, is my wrong answer. So therefore A, C, D are the right answers. For more details about the uniform continuity, you can watch about my lecture on PYQ of the uniform continuous. If you already watched them, PYQ of the uniform continuous, PYQ of the continuity, then you will get the easiest explanations and the understanding. If you are really interested to join with me for more discussions, you can watch or you can scan and join my WhatsApp group. It's always a free of cost to everyone. I will upload the next part very soon. Till then, you can share this video with your friends. You can like and comment on this video. Happy learning always. Thanks for the watch.